Today we are starting a new topic, that is application of definite integration. In this topic we are going to see how to find area under a curve, area under a curve. How to find area under a curve. Now when I say area under a curve, what does that actually mean? So in order to study this in detail, let's go for the actual diagram. So what I do is I make x-axis and y-axis. This is y-axis, this is x-axis, and then I make a curve. The curve is y equal to f of x. So this is y equals to f of x, the curve. Now I want to find the area of the region under this curve. I want to find the area under this region, area of the region under this curve. Now when I say area of the region under this curve, one has to understand that this curve might be going to infinity. We are not certain about it. See, it might go like this to infinity. You understand? And this side also it may go to infinity. So the region under this curve, the region under this curve is not specific, not specified. So what we need to do is we need to specify the region under this curve. So for that we will need the boundary. We will need the boundary. So here starts my actual statement. I will write here area under the curve, area under the curve, y equal to f of x. Then I write bounded by x equals to a and x equals to b. Now when I say x equals to a and x equals to b, what does that mean? See, it can be understood that a and b are two numbers on x-axis. You can take it that way. What you can say? You can say a and b are two numbers on x-axis. Now, when you draw a straight line passing through x equals to a and parallel to y-axis, you see this line passing through x equals to a and parallel to y-axis. Now this straight line is nothing but x equals to a. This straight line is x equals to a. You know, every point on this line will have x coordinate a. So the equation is x equals to a. The equation is x equals to a. Similarly, you can have another straight line which is passing through point B, and parallel to y-axis. See, and this is x equals to b. So now your area is specified that you want area under the curve y equal to f of x. You want area under the curve y equal to f of x, bounded by these two lines. Which two lines? See, this line and this line. Okay. Now there is something more to it. When I say area under the curve, remember it is always up to x-axis. So when I say area under the curve, it is always up to x-axis. Now what does that mean? See, area under the curve, but it will only be up to x-axis. See here, up to this. It will not go beyond that, because then this is, it doesn't mean that way. It doesn't mean that way. That's it. When you say area under the curve, it doesn't mean these. No, it is not correct. It is not correct. It is only up to x-axis. So area under the curve only up to x-axis. That one has to understand. So what way it will be? It will be, see this. It means this area. Under the curve up to x-axis, it means this area. You can check. Area under the curve up to x-axis is this shaded area. This shaded area. So what have I written so far? I have written area under the curve y equals to f of x, bounded by lines x equals to a and x equals to b, up to x-axis, up to x-axis, up to x-axis. So this particular diagram, please, this particular diagram which I have drawn here, this diagram, along with this statement, they go hand in hand. They are made for each other. Remember, this diagram means this statement, and this statement means this diagram. One has to understand this. Now, there are ways I can write this statement. There are different ways I can write this statement. So this is one way of writing the statement. I can make some changes here, but it will still mean the same. Okay, so I'm writing by making some changes here. I can also write area under the curve y equals to f of x. I can write area under the curve, y equal to f of x in the interval, AB. See, instead of writing in the bounded by, instead of writing bounded by x equals to a and x equals to b, this time I'm writing in the interval AB. It has the same meaning, please. Then up to x-axis, up to y equals to 0. Now see, instead of writing x-axis, I'm writing y equals to 0. Because x-axis has equation y equals to 0. Once again, it has the same meaning. Once again, it has the same meaning that you have to understand. Okay. So what you will now do is you will copy this two statements and you will draw the diagram. Please do it. Do it fast. Now, the next point we are going to take is we will make a change here. Instead of writing area under the curve y equal to f of x bounded by x equals to and x equals to b up to x-axis, what if I have up to y-axis? Try to understand. See, area under the curve up to y-axis. Now, when you say area under the curve up to y-axis, that will be somewhat like this. See, this is your curve and area up to y-axis. You see this? This is area up to y-axis. This is area up to y-axis. So just now we did area under the curve y equals to f of x bounded by x equals to a and x equals to b up to x-axis. Okay, I told you that this statement and this diagram, they go hand in hand. Now the next I will be doing area under the curve up to y-axis. But before I do that, I want to get you the mathematical expression for this. the mathematical expression for finding this area under the curve, to find area under the curve, to find area under the curve, under a curve. So now you have understood that there is a curve y equals to f of x. You have understood that the area is bounded by this line and this line up to x-axis, and that area means this shaded portion. You have understood this part. The question is, how do I find it? How do I find this? See, for that I'm going to get you the mathematical expression. The mathematical expression is integral f of x dx, integral f of x dx from a to b. When you evaluate integral f of x dx from a to b, you will get this area. Mind it. What you will get? You will get this area. This area. Which area? The one that you just spoke about. This area you will get. For that, what you will have to do? As I said, you will evaluate a to b f of x dx. Okay. Why? Why f of x dx? Because we are finding area under the curve y equal to f of x. That is why a to b f of x dx. So then you can ask me that here we have y equal to f of x. So could we write here a to b y dx? Is it possible? Can we write a to b y dx? Yes, even that is possible. You can write a to b y dx. Both are equal. Both are equal. A to b f of x dx is same as a to b y dx because y equals to f of x. Y equal to f of x. Okay. So what we will write now? We will write here, this area A. Let us write that area as A. Okay, is given by, this area A is given by A equals to A to B f of x dx equals to a to b y dx. You can write a to b f of x dx or a to b y dx. Please copy this also. Please copy this as well. Copy this in your notebook, this part. So now remember students, if I ask you, how do you write, if I ask you, how do you write area under the curve y equal to f of x bounded by x equals to a and x equals to b up to x-axis, up to x-axis, up to x-axis. How do you write this? So your answer will be, we write this as equal to a to b f of x dx or a to b y dx. Now after this, I will teach you what if you have area under the curve up to y-axis. So for that, I draw the diagram. See here, I draw y-axis, I draw x-axis, draw y-axis, x-axis, and then let's have the curve. The curve is, this is y-axis, x-axis. Let's have the curve. The curve is, say this. And this time the curve is not y equal to f of x. Remember, if you are finding the area under the curve up to y axis, if you are finding area, if you are finding area under the curve up to y axis, then remember it's going to be x equals to g of y. Don't write y equal to f of x. What will it be? It will be x equals to g of y, not y equals to f of x. So area under the curve x equals to g of y. You express here x in terms of y. Then what will you write next? You will write bounded by y equals to a and y equals to b. Try to understand the difference. Bounded by y equals to a and y equals to b up to y axis, up to y axis. So what you have here is y equals to a and y equals to b are two numbers on y axis. This is a, this is b. A and b are two numbers on y axis. You know y equals to a is nothing but a line which is passing through a and it is parallel to x axis, and y equals to b is another line which is passing through b and it is parallel to x axis. So these are two lines, y equals to b, y equals to a, and the area concern is area under the curve. You can check, see area under the curve, under this area under the curve bounded by y equals to a, y equals to b up to y axis. So we are talking about this area. You can check, see, we are talking about this area bounded by the curve. So we will not go here, not allowed. You cannot go here, you cannot come here. Why? Because the area is bounded by these two lines. Which two lines? Y equals to B, the area is bounded by these two lines. So it has to be this side only, this side, and it has to be this side. Okay. Bounded by two lines. The area is bounded by two lines. So area under the curve bounded by y equals to a, y equals to b, this area we are talking about. Up to y axis. Now when you say up to y axis, you will get this area. Say this area is A. I write this area as A. This area is A. How will I write this mathematically? How to express this area mathematically? So mathematically, I'll be writing integral. For this, we will write integral A to B and g of y dy. Try to understand. It is A to B g of y dy. You can compare with what you had written first. See, here you wrote A to B f of x dx. Here you wrote A to B f of x dx. Why you wrote A to B f of x dx? Try to understand. Because here the area is up to x axis. Try to understand. The area is up to x axis. So remember, when you say area up to x axis, it has to be with respect to x. It is the area which is spread along x-axis. Area is spread. Try to understand. See, the area is spread along x-axis. It is spread along x-axis. So It has to be, the integral has to be with respect to x, dx. Got that? Now here you are saying area up to y-axis. So it has to be with respect to y, dy. See, the area is spread along y-axis. It is along y-axis. So first thing is what? Area up to x-axis, you will have dx. Area up to y-axis, you will have dy. Next, if you have dx, then it has to be function of x. So f of x. If you have dx, it has to be function of x, and after that it is the interval a to b. Same way here, if it is dy, has to be function of y. So g of y, and the interval a to b, and the interval for y-axis a to b. Okay. Now, as you know, f of x is y. So because y equals to f of x. So f of x can also be written as y. So a to b y dx. Likewise, here we will write a to b g of y dy, or we can also write this as a to b x dy. We can also write it as a to b integral a to b x dy. So both of them are correct. You can write this. So I will now write it properly. I will write here this area, A is given by, it is given by A equals to, you can write A equals to A to B g of y dy, or you can write A to B x dy. Okay, please copy this fast. We can write this as second, and here we will write this as first. So now remember, students, we have two cases. The first case is area under the curve up to x-axis. This is first case. Area under the curve up to x-axis. You know the thing. It is curve like this and area like this. Okay, this is first case. And what's the second case? The second case is area under the curve up to y-axis. This is your second case, area under the curve up to y-axis. So area like this, and the curve like this, and the area like this. Okay, so these are two cases we have, and for both the cases we have the mathematical representation. And you saw that in both the cases the mathematical representation is nothing but definite integral. Definite integral. So here we learn the application of definite integral. What is application of definite integral? We can find the area under the curve. So application of definite integral is we can find the area under the curve. Now for these two cases, we have different sub cases. Okay, so just now what I said, we have two cases, area under the curve up to x-axis. Second case, area under the curve up to y-axis. Now I'm going to show you some sub cases. So first A. Now when I write first, what does that mean? Area under the curve up to x-axis and A. So A is its sub case. Now see, what is that sub case? What do I mean by sub case? So here I have x-axis, y-axis, and this is x-axis. Okay, this is x-axis, and the curve is this. See, this is the curve. This is curve y equal to f of x. And then I need the boundaries. You know the boundaries will be two lines. parallel to y-axis. So x equals to a, say here x equals to a and x equals to b. This is line x equals to a, this is line x equals to b, this number is a here and this number is b. Now what way this diagram is different from the first diagram, you can understand. See the first diagram, what had happened here? See in this diagram, what we noticed was in the interval a to b, the area bounded by two lines x equals to a and x equals to b. In this interval, the function is not crossing x-axis. What I mean is, in between numbers a and b, in between numbers x equals to a and x equals to b, you notice that function is above x-axis. The function is completely positive. For x equals to a to x equals to b, for all these numbers, y, the value of y is positive. You check, these are all up. These are all above x-axis. Whereas in this case, which I took, what you notice that between the interval x equals to a and x equals to b, in between these two numbers, the function y equal to f of x crosses the x-axis. The function y equal to f of x is crossing the x-axis. Say this is c. Say this number where it is crossing the x-axis is c. So what is happening? Unlike the previous case where for all the x values y was positive, here for some x values y is negative. You can check. For these x values, the y value is negative. It is below x-axis. It is below x-axis. You understand? And here it is above x-axis. So this case, we will say, this case is the case where the curve is crossing x-axis. Okay, the curve is crossing x-axis. Now what happens is the area, the area which is below x-axis, it is considered to be negative area. It is considered to be negative area. And the area which is above x-axis, it is considered to be positive area. This area is positive area. So when we are asked to find area under the curve, now try understanding this. When we are asked to find area under the curve, area under the curve y equal to f of x up to x-axis, bounded by x equals to a and x equals to b. Okay, for this diagram what we will do is we will calculate two areas. Remember, you cannot directly calculate the way you did in the previous case. I repeat again, if you have to find area under the curve for this particular case, what does that mean? It means area up to x-axis under the curve. It is this area plus this area. You understand? Up to x-axis. What happens is when you say up to x-axis, it becomes two areas. Earlier it was like this. It was only this, but now it is this as well as up to x-axis. So this also you will have to consider up to x-axis. Now you notice that one area is below x-axis, which is the negative area. So what you will do is you will divide this into two. You call this as A1 and this as A2. You find these two areas separately. You will find these two areas separately. So what will be area A1? Try understanding. What is A1 here? A1 is, let us now define A1. A1 is area under the curve. See, A1 starts from C to B. Where does A1 start from? It starts from point C, it goes up to B. So A1 is integral C to B f of x dx. Integral C to B f of x dx. This is A1. And you will also find A2. A2 goes from area A2. It starts from point A, it goes up to C. So it is A to C f of x dx. A to C f of x dx. And remember students, this A1 which you will find, it will be a positive area, but A2 will be negative area. So what you will have to do is, you will have to find the positive value of that. You will have to ignore that negative sign. I repeat again, what you will do, you will ignore the negative sign. For that, you will do mod of A2. What you will do, you will do mod of this area. That is, whatever sign you get, it gets ignored. It gets ignored. So A1 is positive, no worries. A2 is negative, so you will find mod of this. So in such cases, what we do on safer side, we will put mod of A1 also. Let it be, if it is positive, mod of positive will be positive only, so let it be, no worries. So what we will do, we will find mod of A1, mod of A2. And what will be the area now? The area will be it will be A1 area under the curve y equals to f of x up to x-axis bounded by this is given by mod of A1 plus mod of A2. It is given by mod of A1 plus mod of A2. Why write mod here? Because the curve is crossing x-axis. The curve is crossing x-axis. That's why we write mod. Now we know here from the diagram, we know that for A1 the mod was not required. Let it be, no worries. Let it be. Suppose this area you get 7 and this area you get -5. Okay. So what will happen? You will get mod of 7 plus mod of -5. That is equal to 7 plus 5. That is equal to 12. The answer is 12. So 7 remains 7 only and -5 became +5. Okay. So this thing you will follow. This thing you will follow. It is given by mod of A1 plus mod of A2. That is equal to mod of A1 is mod of A1 C to B f of x dx plus mod of A to C f of x dx. You will copy this also. Please do it fast. So what can be the heading here? The heading can be area under the curve y equal to f of x when it when it crosses x-axis. This is the heading. This can be the heading. Area under the curve y equal to f of x when it crosses x-axis. See, the curve has crossed x-axis. Okay. Now we will go for the next. See, this was 1a, area up to x-axis. And what does A mean? A is the sub case. Now we go for 1B. As I told you, we will go for different cases for 1 and 2. So we'll go for 1B. 1B is the heading. I will write the heading later. First of all, I will explain you what I actually mean by this subcase. So let me draw the diagram here. So here I have y-axis and this is x-axis. Okay, y-axis. Now I have two curves here. One curve is say y equal to f of x, and the other curve I have is y equal to g of x. Y equal to g of x. So I'm interested in the area between these two curves. What am I interested in? I'm interested in area between the two curves. That is, I'm interested in this area. To be precise, I'm interested in this area. You can check between the two curves. Area between two curves. See this area I'm interested. Okay, I'm interested in this area. Now what I notice is this area lies between the point of intersections of these two curves. So the first thing I would do is I shall find out their point of intersection. So say the point of intersection is this point, which is along x-axis, it is A and B. So what is the point of intersection? It's A and B. Along x-axis, it is A and B. See, definitely this point will have some y coordinate also. The x coordinate is A. The x coordinate of this point is A. And the y coordinate will be f of A or g of A, because at x equals to a, y is f of a or y is g of a, either. But then we are not interested in the y coordinate. Why? Because we are going to get the area along x-axis, the spread. We are going to consider the spread of the area along x-axis. So these two curves, y equal to g of x and y equal to f of x, they intersect each other. They intersect each other at point, let me call this as point A, where the x coordinate is A, and point B, where the x coordinate is B. Okay. Now I shall be finding two areas. What I'll be doing, I'll be finding two areas. Let us understand what those two areas are. See, first I will find area under the curve. I shall find out area under the curve y equal to f of x in the interval y equal to f of x in the interval A to B up to x-axis. See, I will find out this area. I will find out this area. Okay. I will find out this area. Area under the curve y equal to f of x in the interval A to B up to x-axis. So this area I show it by shading this way. See, this is the area I'm talking about. Okay, and how do I write this area mathematically? It is the area under the curve. It is area under the curve y equal to f of x. So mathematically it is a to b f of x dx. A to b f of x dx. And I will write this area as, say, a1. This is my area a1. Then I will go for area under the curve y equal to g of x up to x-axis in the same interval. In the same interval, what does that mean? It means now I shall find out this area. See, area under the curve y equal to g of x. See, I shall find out this area. Area under the curve y equal to g of x. Area under the curve y equal to g of x in the interval a to b, in the interval a to b, this interval up to x-axis. So that area I show by shading. See, I show it by shading this way. See, this is the area which I'm going to find next. And mathematically, how will it be given? You all know it. Mathematically, it will be given a to b, a to b, g of x dx. Why g of x? Because it's the area under the curve y equal to g of x. So you will integrate the curve a to in the interval a to b, which curve? G of x. And let us write this as a2. Now you can understand you have area a1, which is area under the curve, which is area under the curve y equal to f of x. You have area under the curve y equal to f of x. This area you have. Okay, and then you have area under the curve y equal to g of x. You have this area. Okay, if you subtract, a2 from a1, what you are going to get is the area that you are interested in. You are going to get this area. You are going to get this area. If you get the difference of these two areas, you are going to get this area which you are interested in. I hope you all must have followed. So here I will write, therefore, I will write here area between the curves, area between the curves, area between the curves y equal to f of x and y equal to g of x is given by, it is given by a1 minus a2. A1 minus A2. Why? Because A1 is bigger area, A2 is smaller area. But then what happens, students, not every time you will be drawing the diagram. Not every time you will be able to get the sketch. So what happens if you subtract the larger area from the smaller area? You will get a negative sign. Now, in order to protect your answer, you will put this in mod. So let us write this in mod. So it is what? Mod of a1 minus a2. So what happens, if even if it is smaller minus larger, the negative answer that you get, it gets omitted. It will get omitted. So a1 minus a2 in the mod. Area between the curves y equals to f of x and y equals to g of x is given by mod of a1 minus a2, where a1 and a2 you already know. So what do you think should be the heading? The heading here is, we can write the heading as area between the curves. The here heading is area between the curves. Please copy this fast. Please copy this. So after learning the concept, here we have few problems that we will now be solving. The problem is from exercise 5.1. It is from exercise 5.1. I am referring to Maharashtra State Board textbook, exercise 5.1, Maharashtra State Board textbook I am referring to. But the concept is useful for all the boards, whether it is CBSE board, ISC board, the concept remains the same. Even the problems, most of the problems you will find that they are repeated in the other board textbooks. So let's see what the question is. We will solve all these questions. So it says, find the area of the region bounded by the following curves. Find the area of the region bounded by the following curves. Then it says x-axis or maybe y-axis, x-axis, or in some cases it may be up to y-axis. You know, I showed you two cases. One case was area up to area under the curve, up to x-axis, and in the other case, if you remember, it was area under the curve up to y-axis. Okay, so it talks about both the cases, up to x-axis or up to y-axis, and the given lines. Then also, if you remember, I showed you that if the area is up to x-axis, then it is bounded by two lines. So say if this point is A, this point is B, then it is x equals to A and x equals to B, this way. Okay, or if the area is up to y-axis, then it is bounded by two lines, and if this is A, this is B, so you call this line as y equals to B and this line as y equals to A. Okay, so reading the question and understanding its meaning is more important. If you have understood the meaning of the question, you can easily answer it. So let's read it once again, what the question is. The question says, find the area of the region bounded by the following curves. See, so now here in the first question, y equals to 2x. See, this is the curve up to x-axis and the given lines. It is bounded by two lines, x equals to 0 and x equals to 5. Okay, so the curve is y equal to f of x. Remember students, if I notice curve y equal to f of x, then I understand the area up to x-axis, If you want, you write it down somewhere. If I notice the curve y equal to f of x, then it is area up to x-axis. And if I notice the curve x equals to g of y, then it is area up to y-axis, Now, when I have area up to x-axis, then the lines I have will be x equals to A and x equals to B. And if I have area up to y-axis, then the lines will be y equals to A and y equals to B. These will be the boundary lines, Okay. So I hope you have followed this. So let us start solving these questions. So I will begin with the first one. First answer for the first one. The curve is y equals to 2x, and if I see y equals to 2x, I understand it is area up to x-axis, and the boundaries are 0 to A and 0 to 5. So I will write area A equals to 0 to 5. You can check 0 to 5. F of x dx. What is f of x? 2x. 2x dx. That is, 2 is constant 0 to 5 x dx. 2 is constant, 0 to 5 x dx, that is 2, and integration of x is x square by 2, 0 to 5. Okay. Now this 2 will go out, this 1 by 2 will cancel this 2, and then you have x square 0 to 5. This 2 cancels, you know the next step, upper limit minus lower limit. So wherever x you have, you write 5. So you have 5 square minus 0 square. Answer is 25 minus 0, that is equal to 25. Answer is 25. This is the answer. Okay, now after first, we'll go for the fourth one. See, the curve is y equals to sine x. Once again, it is in the form y equals to f of x. And if it is y equals to f of x, it is the area up to x axis, and the boundaries have to be x equals to a and x equals to b. So from x equals to 0 to x equals to pi by 2. So I will write here the fourth one I solve for you now. Let's solve the fourth one. Y equal to sine x it is. So here I have area A equals to, what's the interval? Interval is 0 to pi by 2. The interval is 0 to pi by 2. Interval is 0 to pi by 2. 0 to pi by 2 sine x dx. So I have here integration of sine x is minus cos x and 0 to pi by 2. Now this negative sign can be taken out. So negative is out. I have here cos x and 0 to pi by 2. 0 to pi by 2. So this is minus here. So cos pi by 2 minus cos 0, upper limit minus lower limit. So negative of 0 minus 1, the answer is 1. So what's the area? The required area equals to 1. This is answer. Copy this. Now let's go for the fifth one. It is x into y equals to 2. It is x into y equals to 2. So what I will write is xy equals to 2 is the curve. I will write this as y equals to 2 by x. Y equals to 2 by x because I want it in the form y equal to f of x. So see here I write the given curve is the given curve is fifth one. The given curve is xy equals to 2. Therefore, y equals to 2 by x. Y equals to 2 by x. And what are the boundary lines? The boundary lines are x equals to 1 and x equals to 4. Remember, the moment you write this y equal to 2 by x, it means it is in the form y equal to f of x. So it's along x-axis, and hence the boundary has to be x equals to a, x equals to b. This I have already told you. This I have already told you. Okay, so here we have so 2 by x, and so therefore the area, the required area a equals to, it is from 1 to 4, 1 to 4 and 2 upon x dx. So this 2 is out. I write 2 out here. This is 1 upon x dx and 1 to 4. Integration of 1 upon x is log x. So here 2, then I have log of x and 1 to 4. So this is upper limit minus lower limit 2 times log of 4 minus log of 1. Now you know log 1 is 0. So the final answer is 2 log 4, or you can write log of 16, 4 square 16. This is the final answer. So now after fifth, we are going to start with question number 6. Look at this sixth one. It says the curve is y square equals to x. The curve is y square equals to x, and the area required is bounded by x equals to 0 and x equals to 4. So here I will write Sixth problem, the given curve is y square equals to x, and required area is bounded by two lines, x equals to 0 and x equals to 4, by x equals to 0 and x equals to 4. Now, as you know, students, as you know here, that I can have the curves, I can have the equation of curve in two form. It can either be, see, it can either be y equal to f of x, or it can be x equals to g of y. Okay, it has to be one of these. Now here I understand, observe this problem very carefully. Here I understand that I'm given the curve in the form y equals to g of y. See, I'm given the curve in the form y equals to g of y. You see this, y equals to g of y. It is, I'm sorry, I'm given in the form x equals to g of y. Here I'm given in the form x equals to g of y. I'm not given in the form y equal to f of x. It is not y equal to f of x. It is x equals to g of y. Okay. Now I understand, if I have x equals to g of y, then the boundaries have to be y equals to a to y equals to b, right? If I have the curve x equals to g of y, it means I'm going to find the area up to y-axis. And if I'm finding the area up to y-axis, the interval have to be from ya to yb, from y equal to a to y equal to b. But that is not happening. Though I have x equals to g of y, you can check, though I have x equals to g of y, but the boundaries are from x equals to 0 to x equals to 4. Now this makes me understand that I have to convert this equation in the form y equal to f of x, because the boundaries given are on the x-axis. Try to understand, x equals to 0, x equals to 4, x equals to 0 to x equals to 4. So x equals to 0 is here and x equals to 4 is here. I'm given the boundary lines, I'm given the two boundary lines along x-axis, along x-axis. So the area has to be this way. And if the area has to be this way, I need to get the curve y equal to f of x form. Y equal to f of x form. X equals to g of y will not work. And then what I understand, that though they give me y square equals to x, I will write this as y equal to square root of x. What I will do, I will write this as y equals to plus or minus square root of x. This is how I will write. I will write this equation in the form y equal to f of x. Okay. So the first thing I do is I draw the curve y square equals to x. I know this curve. What this curve is? This curve is a right opening parabola. Y square equals to x is a right opening parabola. So I draw that curve, y square equals to x. This is y square equals to x. Okay. And I want the area under the curve up to x-axis in the interval 0 to a. Now you all know x equals to 0 is here, and x equals to 4, x equals to 4 is somewhere here. You see this, x equals to 4. This is 4. So what exactly the area required? Exactly the area required is this area. See, we want area under the curve We want area under the curve up to x-axis, in the interval 0 to 4. Now remember students, if you all are thinking that why am I going below x-axis, so for that the reason is well written in the question itself. You can read the question, what the question was. The question was, find the area of the region bounded by the following curves. It is clearly said bounded by the curves x-axis, bounded by the curve x-axis and the given lines. So if you see the area bounded by the curve, so area bounded by the curve and x-axis, if you see, then it clearly indicates that the curve, area bounded by the curve, the x-axis and two lines. So the two lines are x equals to 0, x equals to 4. X equals to 4 is this line. Okay, x equals to 0 is your y-axis, x equals to 0 is this line. Now see, the area bounded by the curve, and the curve is y square equals to x. So this curve, these two lines and x-axis, you have this particular area, okay, as well as this area. You understand? You have these two areas. Now I know that these two areas are symmetric. You know, these two areas are equal to each other in magnitude. Whatever area I have above x-axis, okay, whatever area I have above x-axis, below x-axis, it is exactly equal because the parabola is a symmetric curve. You got that? The parabola is a symmetric curve. So what I will do is, I will calculate this area, that is, I will calculate the area under the curve up to x-axis. I will calculate this area, and then I will double that area and I will multiply by 2. So after calculating this area, when I multiply by 2, I will get the required area. So I will write here, see, I will write the given curve is y square equals to x. This is 1. I will write here from 1 we can write, from 1 we can write, what you can write, y equals to plus minus square root of x. Okay, plus minus square root of x. But remember students, what am I going to do? What am I going to do? I'm going to find out this area, which just now I showed it to you. I'm going to find out this area. Now this area is under which branch of the curve? Which branch of the curve? It is under this branch. It under this branch. Okay, the area which I'm going to find out, it is under this branch, and this branch is in first quadrant. And you know, in the first quadrant, y is positive. Y is positive. So what I will write here, I will write, in first quadrant, in first quadrant, in first quadrant, y is greater than 0. Therefore, y equals to square root of x, positive. Then I will write, here the required area. I write here, let the shaded area equal to A. Let the shaded area be equal to A. This one be A. So I will write, therefore the required area equals to 2 times of A. And what is A? Or you can do one thing. Let us first find out the shaded area, and after that we will multiply 2. So I will write there A equals to 0 to 4, 0 to 4, and f of x dx. What is f of x dx here? It is root x, 0 to 4, root x dx. That is 0 to 4, x raised to half dx. That is integration of x raised to half is x raised to half plus 1, 3 by 2, upon half plus 1, 3 by 2, and 0 to 4. Okay. So now I have area equals to, this 3 by 2 will come out as 2 by 3, 2 by 3, and x raised to 3 by 2, 0 to 4. That is 2 by 3, and now I have upper limit minus lower limit. 4 raised to 3 by 2 minus 0 raised to 3 by 2. That is equal to 2 by 3. 4 raised to 2 by 3. 0 raised to 2 by 3 by 2 is 0. 4 raised to 3 by 2. I can write that as 2 square raised to 3 by 2. Okay. Now this 2 and 2 cancels. I will have 8. Okay, 2 cube is 8, so I get here, therefore A equals to 2 by 3 into 8, so A equals to 16 by 3. Okay, I got this area as 16 by 3. Which area? This area I got 16 by 3. So the required area is double of that. Okay, double of that. I will write, therefore the required area equals to 2 times A, that is 32 by 3. This is the required area. I hope you all followed it. Please watch this again and copy. Now you will all solve this problem on your own. Y square equals to 16x. As I solved y square equals to x, you will solve now y square equals to 16x. What will happen? You will write here y equals to plus or minus square root of 16x, which is plus or minus 4 times root x. But in first quadrant it's going to be only positive 4 root x. So you will find out the area for the first quadrant, and then you will multiply 2 as I did. Don't forget to draw the diagram. Please draw the diagram. Okay, and the diagram will be exactly same parabola which I drew for y square equals to x. Please go ahead, solve this problem, get the answer. The answer for this you will get is 128 by 3. What is answer? Answer is 128 by 3. So now the next problem we will take is second problem. We are left with second and third, these two problems. Let me solve second problem. In the second problem, we are given the curve as x equals to 2y. So see, when I am having x equals to 2y, it is in the form x equals to g of y. It's in the form x equals to g of y. So it means it is up to y axis. Then the boundaries have to be in the form y equals to a to y equals to b, and that is what the boundary is given as. So everything is proper here. So we will go for solving problem number. We will go for solving problem number 2. So I solve this here. So see, second. The given curve is x equals to 2y. So I will write area A equals to a to b g of y dy. Okay. So a to b, that is 0 to 4, 0 to 4, and g of y. What is g of y? G of y is 2y and dy. Now this 2 will go out. You have here y dy and 0 to 4. So that is 2 is out. Integration of y is y square by 2, 0 to 4. This 2 will cancel this 2. Upper limit minus lower limit, you have 4 square minus 0 square. So the answer is 16. What's the answer? 16. You can copy this fast. Let's go for the last question in this section, which is question number 3. Now in question number 3, you notice that you are given total 4 lines. You are given x equals to 0, x equals to 5, y equals to 0, and y equals to 4. Now in the first go, a student will think, okay, let me write the question once again here. Question number 3 we are solving. I'm sorry. We are solving question number 3. So what we are given, see, We are given x equals to 0, x equals to 5, y equals to 0 and y equals to 4. So all these are actually speaking lines. They all are lines. If I take this as y-axis and this is my x-axis, then I understand x equals to 0 is y-axis. See, x equals to 0 is y-axis. Okay, it's a line parallel to, it's a line passing through x equals to 0. It's a line passing through 0 and parallel to y-axis, which is nothing but y-axis. What is x equals to 0? X equals to 0 is equation of y-axis. This is x equals to 0. This is x equals to 0. Then I have x equals to 5. What is x equals to 5? X equals to 5 is a line which is parallel to y-axis and passing through x equals to 5. Got that? So this is x equals to 5. See, this is x equals to 5. Here I have x equals to 5. Then I am given two more lines, x equals to y equals to 0 and y equals to 4. What is y equals to 0? Y equals to 0 is x-axis. This is y equals to 0. This line is y equals to 0. This line. See this? This line is y equals to 0. And finally, I am given one more line, y equals to 4. Y equals to 4 is this line. See, it is parallel to x-axis and passing through 4, number 4 on y-axis. So as such, I'm given here total 4 lines. So the thing is, which is my y equals to f of x? Where is the function given? Where is the curve given? Where is the equation of curve? See, it's all up to me. I can consider this as my curve. I can consider, see, I have to, which area do I have to find? I have to find this area. First, let us talk about the area that I have to find. So this is the area I have to find. Okay. How do I know this is the area I have to find? Because it is clearly said. What is said? It is said area bounded by the curve and the given lines. So area bounded by this 4 lines I'm given. So what is the area bounded by these lines? This is the area bounded by the line. So I have to find this area. Now, if my concern is this area, it is all up to me. How do I perceive this area? How do I take this area? How do I consider this area? See, I will take it this way. I will take y equals to 4 as my function. I will take y equals to 4 as my function. Okay. And I shall find out the area under this curve. I will find out area under this curve up to x-axis in the interval 0 to 5. I repeat again. What I do, I will take y equals to 4 as my, I will take y equals to 4 as my curve. See, this is y equal to, I will take this as y equals to f of x. What is f of x? F of x is a constant function 4. So I take y equals to 4 as y equals to f of x. Y equals to 4, I take y equals to f of x. Then I will find out area under this curve up to x-axis, in the interval 0 to 5. Okay, so I will write, therefore the required area is, I will write here, therefore the required area is given by, it is given by a equals to, see, in the interval 0 to 5, you understand, in the interval 0 to 5, in the interval 0 to 5, so 0 to 5, and f of x dx. What is f of x? F of x dx. What is f of x? F of x is 4. So 0 to 5, 4 dx. 4 is out, constant. So I have 0 to 5, 1 dx. And integration of 1 is x. So I have 4 and x here, 0 to 5, upper limit minus lower limit. So what I will get? I will get 4 times 5 minus 0. Wherever x, write upper limit, then write lower limit and subtract. So the final answer is 20. What is the final answer? 20. I hope you got this. Please see this again, watch this, watch the whole video again and solve these problems several times. Remember the concept which I taught you in the beginning, that is case 1, case 2, case 1a, case 1b. Those concepts are most important. You have to draw those diagrams and learn those statements with the diagrams. Okay? Thank you. Bye.